Thank you so much for attending this talk, Architecture for Flow with Wardley Mapping, Domain-Driven Design, and Team Topologies. And as have heard today, the talk title with the most buzzwords in it. So let's try to analyze all these buzzwords, and there are even more. So most initiatives that try to change or optimize the system are usually located or targeted at improving parts taken separately. So most initiatives tend to focus on local optimization of separate parts of the system. But from a system thinking lens, local optimization of separate parts will not improve the performance of the whole. Dr. Russell Eckhoff, one of the pioneers of the system thinking movement, stated that if the system is more than the sum of its parts, it's a product of the interactions. And the way the parts fit together, that determines the performance of a system, not on how they perform taken separately. He also claimed if the systemic nature of a system or organization is ignored, the effort of improving or changing that system are doomed to failure. So when we are building systems in general, we are facing with the challenges of building the right thing and building the thing right. Building the right thing addresses effectiveness and addresses questions such as how aligned is our solution aligned to the user and business needs? Are we generating value for our customers? Have we understood the problem? And do we share a common understanding? Building the thing right, on the other hand, focuses on efficiency. For example, how efficient are our engineering practices? And it's not only crucial to generate value for our customers, but also being able to deliver that value to our customers. And how fast can we deliver changes? And how fast and easy can we make a change effective and adapt to new circumstances? So the one does not go without the other, but as Dr. Russell Eckhoff pointed out, doing the wrong thing right is not nearly as good as doing the right thing wrong. So by considering the whole and having effectiveness and efficiency in mind to build the right thing right, we might need a holistic perspective, a holistic approach to build adaptive systems. And one approach that I would like to share with you today is combining the perspective of business strategy with Wardley Mapping, software design and architecture with domain-driven design, and team organization with team topologies that you have heard of today already, in order to design, build, and evolve adaptive socio-technical systems that are optimized for fast flow of change. And let's start right away with an example. And we would like to evolve a legacy system. And this legacy system is an online school for junior students. And based on a legacy system, built, run, and supported by functional silo teams. And we start evolving this legacy system by analyzing their current team situation regards to their delivery bottlenecks, their team cognitive load, and so on. So due to functional silo teams, due to handover, the functional silo teams reported a high communication and coordination effort between teams when implementing and releasing changes. Due to handling with a big ball of mud, with a messy model and messy boundaries, leads to a tight change coupling and also tight team cognitive load. It takes a high amount of effort to understand a piece of code. And the teams also reported that there existed no clear ownership boundaries. So they were facing delivery bottlenecks impeding their software delivery performance. Due to on-premise infrastructures, the operational activities consist of configuration, backup and recovery mechanisms, maintenance, including upgrades and security updates, monitoring, scaling, and so on. So the infrastructure teams faced a very high level of operational efforts. But as a reminder from system thinking, if we are planning to locally optimize only separate parts that will not improve the performance of the whole. To improve the performance of the whole, we need to tackle this situation from a broader perspective and also understand the environment an organization is operating and competing in. And this brings us to a Wardley map representing the landscape of an organization. And Wardley map is a part of Wardley Mapping. So who of you have heard of Wardley Mapping before? A few hands are coming up. Awesome. So Wardley Mapping was invented by Simon Wardley. And Wardley Mapping helps you to design and evolve effective business strategies based on situational awareness and movement following a strategy cycle. And this strategy cycle is composed of 5 different sections and is a representation of change and how we need to react to that change according to Simon Wardley. So it starts with the why, the purpose of the business, the why of the business. And in our case, the why is the purpose is to provide high quality education for junior students everywhere and help teachers to engage with their students online. The next section of the strategy cycle is the landscape, visualized with a Wardley map, the landscape an organization is operating and competing in. So let's dive into a Wardley map by creating a Wardley map of our online school example. And the Wardley map itself is composed of a y-axis and an x-axis. And the y-axis represents the value chain. To derive a value chain, it starts with identifying your users first. And your users could be your customers, it could be your shareholders, business partners, internal users, and so on. And in our case, we are focusing on the teachers and the junior students as the users of our online school. The next step to derive this value chain is to identify the user needs. And the user needs are representing the problems that the users would like to get solved. They are the subject area for which we build a product. And in our case, the teachers would like to create course content, they would like to plan a class, they would like to help the students in their learning progress, they would like to evaluate the learning progress of the students would like to study courses, requesting and receiving help, and also receiving evaluation feedback. And both need to sign up and sign in as well. And the users and the user needs, they are representing the anchor of the map at the top of our value chain that all subsequent components are relating to. So let's go to the next components. So the next step to derive this value chain on the y-axis is to identify the components that are fulfilling the user needs either directly or indirectly by facilitating other components in that value chain. And at the top, we have those components that are most visible to users, where the users are touching the system directly. And at the bottom, it gets more and more invisible to the users. So in our case, the teachers and the students are interacting directly with an online school component. It's located at the top of the value chain. And at this stage, we are dealing with a monolithic big ball of mud as a single component that we are going to decompose later into smaller parts when we talk about domain-driven design. And this online school component depends on other components. For example, infrastructure components, such as data storage, search engine, message broker, SMTP server, compute platform running on top of a virtual machine, in our case, in our current scenario. And they are less visible to the user, so they are placed further down of the value chain. And the next step is to take this value chain and the components of our value chain and plot it along the x-axis, going from left to right. So at the left, we have custom built, Genesis with brand new things, then custom built, then product and rental, such as off-the-shelf products or open source software solutions, and commodity and utility on the right spectrum of our Wardley map. And can use then climatic patterns that are impacting our landscape to derive the characteristics for each component and to determine the stage of evolution per component. So there exist climatic patterns. These are describing external forces that are impacting our landscape over which we have no control. That is the next section of our strategy cycle. However, understanding the climatic patterns gives us an idea, helps us, is important to anticipate change and gives us an idea where the landscape might change and where to invest in the future. And Simon Wardley has compiled a list of roughly 30 different climatic patterns. We are not going through all of them, so you can relax, just only 2 of them. And one of the climatic patterns is that this map or the landscape is never static but very dynamic. So everything evolves from left to right through the forces of demand and supply competition. So for example, cloud-hosted services were decades ago non-existent, evolved through genesis and custom build, became product and rental, and now commodity and utility. And while the components evolve through the evolution stages, their characteristic changes as another climatic pattern. For example, their characteristics change from the uncharted domain, where we are dealing with constantly changing, undefined market, uncertain, unpredictable components, unpredictable markets, and more a chaotic domain. And while the components evolve through the evolution stages, it becomes more and more mature, more stable, where we're then dealing with a mature, known, widespread, and commonly understood stabilizing market. And we can use these characteristics per evolution stage to determine the stage of evolution per component. So for example, coming back to our online school example, we can place the online school component as a volatile component which is changing frequently, providing competitive advantage. We can place this, for example, in the custom build evolution stage. And the more stable, widespread, stabilized infrastructure components can go either in product and rental or commodity and utility evolution stage. And we can use appropriate methods per evolution stage, and that's where we're coming to the next section of our strategy cycle, the doctrine. And the doctrine describes universal principles that are applicable for every organization, regardless of their context. And applying these doctrinal principles enables an organization to respond to changes quickly, to absorb changes gracefully. And Simon Wardley has compiled a collection of roughly 40 different doctrinal principles. We are not going through all of them, just one. And so one is these use appropriate methods per evolution stage. And what this doctrinal principle means that we should build components in Genesis and custom build in-house with preferably agile methods. We should use or buy off-the-shelf products or use open source software solutions for components in product and rental with preferably lean methods. And we should outsource components in commodity to utility suppliers or using preferably Six Sigma methods. So coming back to our online school, we are going to build, or we are currently building our online school component in-house with preferably agile methods. And for our infrastructure components, currently at the current stage in product and rental, we are using open source software solutions for search engine, data storage, message broker, and so on. And the virtual machine component, for example, is currently provided as a off-the-shelf product from a system provider. So we started with a team perspective. Let's now go switch back to the team perspective, because we would like to optimize for flow. And to optimize for flow of change from a team perspective requires to avoid functional silo teams with handover. Instead, we need to focus or aim for cross-functional autonomous teams that are responsible for designing, developing, testing, deploying, operating the system they are responsible for. We should avoid handover to other teams. and we should aim for small, long-lived teams as the norm. And the teams need to own the system or subsystem they are responsible for, so they need to have end-to-end responsibility to achieve fast flow. And another aspect is also we need to minimize or reduce the team's cognitive load, because if the team's cognitive load is largely exceeded, it becomes a delivery bottleneck and leading to software quality issues and delays in our process. And while the communication within a team is highly desired, a high ongoing communication between teams, like whenever you have to implement or deliver a change, and if the teams have to constantly communicate and coordinate, this needs to be restricted. And that is where team topologies can help us with. I guess you have heard of it already today. How of you have read the book Team Topologies from Manuel Peisch and Matthew Skelton? Oh, you have a few hands up. Awesome, awesome. So just give a little brief overview. So team topologies comes with 4 different team types. So we have the stream-aligned teams that are aligned to a continuous stream of work. And they are cross-functional autonomous teams. And they are focusing on a fast flow of changes. So in order to be able to focus on a fast flow of change and to be able to deliver feature deliveries, they need the support from the other team types. For example, from the platform teams that are supporting the stream-aligned teams in their delivery of work and are responsible for platforms that the stream-aligned teams can easily consume. And this platform can vary in its level of abstraction. It could be a low-level abstraction of, for example, of infrastructure, networking, cross-cutting capabilities. It could also abstract away at a higher level, for example, also a design system. And the platform teams provide them self-service services and tools that the stream-aligned, for using that platform, that the stream-aligned teams can easily consume. The next team type are the enabling teams, and they support the stream-aligned teams to identify and acquire missing capabilities, or the complicated subsystem teams as an optional team type that are supporting the stream-aligned teams on particularly complicated subsystems that requires a very, very specialized knowledge. And all of these teams, they have the focus to increase the autonomy and reduce the cognitive load of the stream-aligned teams in order at the end to achieve a fast flow of change in the end. But arranging these teams in these team types is not enough to become effective. How the teams are interacting with each other and when to change and evolve the team interaction is also very relevant for organizational effectiveness. So team topologies promotes 3 different interaction modes. So with collaboration, the teams are working very closely together, aiming for a common goal, and but with the hint that they only collaborate for a limited period of time. So a collaboration is short-lived, and collaboration is suitable when discovery, exploration, experimentation together in teams. And the next interaction mode is X as a service. So this suits very well when one team needs a code library, a component, an API, or platform that can be effectively provided by another team as a service. And it suits well where predictable delivery is needed. Or facilitation, where one team would benefit from active help of another team. And this interaction mode is very suitable, it's very, very common or very typical for enabling teams. And the combination of these 4 different team types and the 3 different interaction modes, this promotes organizational effectiveness, but also helps us to apply a collection of the Wardley's doctrinal principles, so that we are, while Wardley Mapping is stating what principles to apply, team topologies helps us how to apply them. So now let's start now and start with our architecture for flow. And to focus on architecture for flow or to optimize the system for fast flow, we need to know where the most important changes in our system occur, the streams of changes. And the streams of changes can vary from organization to organization. So the stream types could be task, role, activity, geography, customer segment related stream types. In our case, we are using our previously created Wardley map as a foundation, and we are using the user needs as activity-oriented stream types that we would like to optimize for flow. So, for example, crazy course content, planning a class, helping students, and so on. They are good candidates for activity streams of changes. And the users and the user needs, they are not only representing the anchor of our Wardley map, but also represent the problem domain when we switch to the context of domain-driven design. And understanding our problem domain and also to distill it into smaller parts, the subdomain, is also a very important aspect for our architecture for flow. And this is where I like to bring in the second perspective of domain-driven design. Who of you have read the Blue Bible of Eric Evans, Domain-Driven Design? Please keep your hand up. Who has read it to the end? A few hands are going down because it took me at least 4 times to read it. It's very wise, but it's really very, very dense, I would say. So, domain-driven design talks about designing software based on domain models. And it comes with a core statement. In order to build better software, its software design needs to be aligned to the business domain, to the business needs, and to the business strategies. And domain-driven design helps us also, as Team Topology did, to apply some of the Wardley doctrinal principles enabling an organization to optimize for fast flow of change. And when we are distilling the problem domain, we are dividing our problem domain into smaller parts, these subdomains. But not all subdomains create the same value for the business. So there are some subdomains that are more valuable to the business than others. So our subdomains, we have different types of subdomains, such as core, supporting, and generic subdomains. And the core domain, that is the core domains that are the area of our system that is most essential, because that's the one that provides competitive advantage. It should be hard for competitors to copy and imitate, so it tends to be quite complex. It changes very frequently in relation to the other subdomains. And that is the part of our system that we need to build in-house. So in a Wardley map, the core domains related aspects, they should go into the genesis or custom-built evolution stage. The supporting subdomains, they are supporting the core domain. They are providing no competitive advantage. They are quite simple, but in comparing to the core domains, they are not changing as frequently as the core domain. And we should watch out for using or buying off-the-shelf products, so using open source software solution, then it would go into product and rental. And if this is not possible, if we need a higher level of specialization, and if you need to custom build it, we need to be aware that this part does not provide competitive advantage, so the development effort should not be too high. Then the generic subdomains, these are subdomains that many business systems have, for example, authentication or payment. And so they are not core, not providing no competitive advantage, but business systems could not work without them. So they are generally complex, but already solved by someone else. So, and they are quite stable. So we should apply using off-the-shelf products or using open source software solution or outsourcing to utility suppliers for the generic subdomains. Coming back to our online school, the user needs of creating course content, planning a class, helping students and studying courses, they fall into the resort of our core domains, and they provide competitive advantage with a high level of differentiation. And they tend to be complex, they change frequently, and they have a low level of ubiquity because otherwise that's not our differentiator to other systems. So our strategic investment should be high for the core domains related aspects. The supporting domains are like evaluating students could be a candidate for a supporting subdomain, so they are not providing competitive advantage, but are necessary for our teachers' experience and necessary for our organization to succeed. Their complexity might be lower and they change less frequently, and we should not invest in that part heavily because it does not provide competitive advantage. And the subdomains or the user needs of signing up and signing in, they embody generic subdomains. And so registration and authentication are subdomains that are widespread, expected, standard in every other business system. And so they have a high level of ubiquity and a high level of stability. And they are usually quite generally complex, but already solved by someone else. So we can, here, the strategic investment should be lower because it does not provide competitive advantage. So in the next section, or another aspect is that first we were like focusing on the problem space of our strategic design of domain-driven design, and also domain-driven design comes also with a solution space of strategic design patterns, and that's where we are decomposing our system into modular components. That's where we are solving our problem in software. And that's where we are decomposing our system into modular components, the bounded context that we already have heard of from previous talks. And the bounded context, they define where a single domain model can be applied, where a single domain model can live in. And they are forming a unit of purpose, mastery, and autonomy, and also provides several different types of boundaries. And one boundary type that I would like to highlight in this talk is that they serve very well as ownership boundaries. I come to back to that one in a second. And designing bounded context and designing domain models requires a close collaboration between domain experts and development teams. And there are different techniques available that can help you with that. For example, event storming, domain storytelling, example mapping, user story mapping, and so on. So in our case, we might have derived some event storming sessions together with the domain experts, and we might have designed following bounded context. So for example, we might have designed the content creation, course studies, class management and learning support, fulfilling the core domain related user needs. These are the bounded contexts that we are going to build in-house, and because these are the bounded contexts that provide competitive advantage. And student evaluation and notification handling, they belong to supporting subdomains, and there might exist solutions on the market already. However, the team decided to custom build these bounded contexts because they require a higher level of specialization, but be aware they don't provide competitive advantage. And the bounded context for identity and access, that belongs to a generic subdomain, and there exist several solutions on the market already. It can go into product and rental or commodity and utility. Another aspect is finding suitable team boundaries, and that's where we come back to our bounded contexts, serving as well-defined ownership boundaries, providing purpose, mastery, and autonomy. And we can use this bounded context as suitable team boundaries for our stream-aligned teams from team topologies. Another aspect that we need to consider is optimizing our team cognitive load. As I mentioned earlier, if it's largely exceeded, it becomes a delivery bottleneck. And that requires that we need to limit the number, type, size of components that a single team can handle. And we can bring this one back to our characteristics of the Wardley map. So if we are dealing with bounded context or components, on our x-axis of components that are located on the left spectrum, for example, on Genesis, then we are dealing with a high level of uncertainty. And a high level of uncertainty requires practices such as discovery and exploration. And for components on commodity, these components are changing far more frequently than components on commodity, for example. For components on commodity, we can draw on best practices, providing a clear path to action. And so every evolution stage in our Wardley map on the x-axis is addressing different practices that you can apply, from best practices, good, emerging, and novel practices. And the more unclear the path to action is, the higher the team cognitive load might be. So that means, as a consequence, as a kind of heuristic, that teams can own more or larger components that are residing on the right spectrum of our Wardley map towards commodity than components on the left spectrum of our Wardley map. Another aspect to optimize for team cognitive load is to create clear ownership boundaries. And this means that we should not share, for example, bounded contexts across teams that would diffuse the ownership of teams. And however, one team can own multiple bounded contexts, but they should not be shared among teams. Another aspect to architect for our architecture for flow is to identify the services that are needed to support a reliable flow of changes. And that's where we come to the platform on a lower level of abstraction, and where then, for example, the streamline teams can rely on services provided by the platform teams. For example, that they are abstracting away the infrastructure, networking, and cross-cutting capabilities for components that are residing on product and rental and commodity and utility evolution stages. And they can start with a Sinus viable platform. That is a platform that is just big enough to fulfill the needs of their consumers. And, for example, it can start with documentation, standards, best practices, and so on, and can evolve later into the digital platform with self-service APIs and tools. As a first idea for our team constellation, we can derive following teams. For example, that the 4 core domain-related bounded contexts can be split among 3 different streamline teams. The supporting and generic subdomain-related bounded contexts can be taken care of by another streamline team, and the infrastructure components can be taken care of by one or multiple platform teams. But before we go into the transition, we have to also consider potential efficiency gaps, because we don't want to build or evolve our system based on inefficiencies, because also inefficiencies impedes our software delivery performance. And one aspect in our example could be, for example, to move our on-premise infrastructure to cloud-hosted services. So right now we have not transitioned anything yet. We have not touched any code yet. We have not reorganized any team yet. And how do we now transition from A to B? How to implement now flow optimization? And implementing flow optimization could be done as one approach by a team-first approach through dynamic reteaming and an evolution of team topologies interaction modes that are supporting and executing, in this case, for example, cloud migration strategy. And since we would like to close our efficiency gaps by migrating our infrastructure components to cloud-hosted services, that's where we are focusing on the infrastructure components first. And this helps us, or this is then the first step could, for example, be that we are forming the platform team first from the previous back-end and infrastructure team members. And this platform team is being built on the site with the full liberty and freedom to learn, explore, discover, and assess cloud migration strategies, for example. And they can determine a migration plan and also determine the new platform. And the platform team, the first form platform team, might decide to start with a replatforming cloud migration strategy. And with replatforming, we are modifying the underlying infrastructure while we keep the application's architecture the same. And we are replacing the on-premise infrastructure components by moving them to the cloud-hosted services incrementally, step by step. But the application's architecture at this point is still the same. And as soon as the infrastructure components from on-premises has been moved to cloud-hosted services, now the remaining infrastructure team can merge into the first form platform team, and later they might split into separate teams as well. So far we have replatformed our infrastructure teams, our infrastructure components, moving from on-premises to cloud-hosted services. But we would also like to modernize our applications architecture to mitigate our bottlenecks. And that's where we move to the next cloud migration strategy of refactoring, where we are splitting apart our application architecture into smaller parts. And we would like to do this by decomposing our monolithic big ball of mud from the beginning into our previously designed bounded context. And for that one, we are then forming next the first streamlined teams from members of the previous front-end and back-end team. So the first streamline team kicks off now the refactoring journey. In the meantime, the remaining front and remaining backend team from the functional silo teams, they can also merge together as one team, taking care of the monoliths as long as it exists as one team with no handover evolved. And later on, we are splitting this merged team into streamline teams as well. But let's go back to the first streamline team. And they're getting support from the platform team along their refactoring journey. So they are collaborating closely together with the first form platform team to jointly discover potential cloud options that are applicable for this specific bounded context that the new streamline team is now responsible for. And the new streamline team might decide we would like to build our bounded context based on serverless technologies. And as soon as the platform team has shared their knowledge and they have discovered the cloud option together, the close collaboration can now evolve into limited collaboration, where you go from day-to-day interaction to on-demand occasional interaction. And this can then evolve later into an X as a service, as soon as the serverless ecosystem is more established in the organization, where then the platform team, the previous platform team, can provide a platform as a service, best practices, standards, tools, APIs that the streamline teams can easily consume for the cloud platform. So we have now refactored the first bounded context, or the bounded context that the one streamline is responsible for, and now the next streamline team can go on their refactoring journey. And they are, by splitting them from the previously merged team, and they can now get active help from the first form streamline team and the first form platform team as facilitation modes. So we have also a different evolution of interaction modes. For example, the platform team can help them how to use the CI/CD pipeline in the serverless ecosystem and so on. And then the next streamline teams goes on through their journey, and they also get support from the previous platform and streamline teams. So that at the end we have decomposed our modular monolithic big ball of mud with a messy model into well-defined bounded context with well-defined ownership boundaries, so that we have optimized our system for a fast flow of change. So coming to the end, I guess this is a sign, so the combination of Wardley Mapping, domain-driven design, and team topologies helps us to understand the environment and landscape and organizations operating and competing in. It helps us to gain domain knowledge and discovering the core domains that provide competitive advantage. It helps us to know what components to build in-house, where to use or buy off-the-shelf products or open-source software solution, and where to outsource to utility suppliers. It helps us to decompose our problem domain into modular components, the bone and context, and helps us to align the teams and evolve their interactions to the system that we are building and the system we plan. And it also helps us to identify potential efficiency gaps and eliminate bottlenecks and increasing our software delivery performance so that we are able to respond to changes quickly. So the combination of Wardley Mapping, domain-driven design, and team topologies, from my perspective, is providing a holistic tool set to build adaptive socio-technical systems that are optimized for fast flow of change, with a focus on improving the performance of a system as a whole. And with that, I'm sharing some resources. And yes, there is so much more to talk about, but I could not talk about in this limited time. So, and I'm writing about it. I will publish a book soonish, hopefully. And with that, thank you.
Well, thank you so much. Perfect timing. We've got one question. Do you have techniques for evolving team composition as the understanding of the domain evolves?
For the for evolving team compositions, it's, I guess, yeah, it's. So sometimes it depends, like, where your domain is located, right? So is it located on Genesis and custom build? So because these are the domain that is frequently changing, and they definitely have to collaborate with other teams to explore it together, to explore domains together, and also to where you have then mostly, like, for example, so Simon Wardley comes also with different aptitude and attitude considerations, where you have teams that are more happy with exploration and discovery, and for bounded context or domains components in product and rental, there you have more mature and stabilizing teams that are happy with this one. And for example, for bounded context and commodity, there the teams are more happy with with maturing and optimizing the parts of the system. But I'm not sure if I've answered the question.
I'm sure it did. Thank you so much. I'm afraid we don't have time for more questions, but Susanne is kind enough to join the panel later tonight. So preserve your questions for 7:15 p.m. It'll be a fantastic occasion to bring them up.
And also around, so if you have a question, please contact me directly, and we can. I'm happy to exchange some ideas.
Wonderful. Please, a round of applause, Susanne Kaiser.
Thank you.